In the world of software development, Git repositories are the backbone of version control. As projects grow, so do the repositories, leading to challenges in performance and manageability. Scaling a Git repository involves strategies to handle large code bases efficiently, ensuring that developers can work seamlessly without performance bottlenecks. This presentation delves into various techniques and tools, including Scalar and cross-repository sharing, to optimize and scale Git repositories effectively. As development teams expand and projects evolve, Git repositories can become unwieldy. Large repositories can slow down operations like cloning, fetching, and pushing changes. This growth can be attributed to an increase in codebase size, history, and the number of contributors. Understanding the nature of this growth is crucial for devising effective scaling strategies. We will explore the common challenges faced and the impact of repository size on developer productivity. Large Git repositories pose several challenges, including slow performance, increased storage requirements, and complex history management. Operations like cloning and fetching can become time-consuming, affecting developer efficiency. Additionally, large repositories can lead to increased network bandwidth usage and storage costs. Addressing these challenges requires a combination of best practices and specialized tools designed to optimize repository performance and manageability. Scalar is a tool developed by Microsoft to help scale Git repositories. It is designed to handle the performance issues associated with large repositories by optimizing common Git operations. Scalar works by implementing advanced techniques like partial clone, background maintenance, and prefetching to improve the speed and efficiency of Git commands. This section will provide an overview of Scalar and its key features, setting the stage for a deeper dive into its capabilities. Scalar offers several features that make it an invaluable tool for scaling Git repositories. These include partial clone, which allows developers to clone only the parts of the repository they need, and background maintenance, which automates routine tasks to keep the repository in optimal condition. Prefetching helps reduce the time taken for fetch operations by preloading necessary data. These features collectively enhance the performance and manageability of large Git repositories, making Scalar a powerful addition to any scaling strategy. Integrating Scalar into your development workflow involves a few straightforward steps. First, install Scalar on your development machines. Next, configure your repositories to use Scalar by enabling its features. This includes setting up partial clone and configuring background maintenance tasks. Finally, monitor the performance improvements and adjust the configuration as needed. This section will provide a step-by-step guide to implementing Scalar, ensuring a smooth transition and immediate benefits. Cross-repository sharing is another strategy to optimize Git repositories, especially in large organizations with multiple projects. This approach involves sharing common components or libraries across different repositories, reducing duplication and improving consistency. By centralizing shared code, teams can streamline updates and maintenance, ensuring that all projects benefit from improvements and bug fixes. This section will explore the concept of cross-repository sharing and its advantages. Cross-repository sharing offers several benefits, including reduced redundancy, improved code quality, and easier maintenance. By sharing common components, teams can avoid duplicating code across multiple repositories, leading to a more efficient development process. This approach also ensures that updates and bug fixes are propagated across all projects that use the shared components, enhancing overall code quality. Additionally, centralized maintenance simplifies the management of shared code, making it easier to implement changes and improvements. To implement cross-repository sharing, start by identifying common components or libraries that can be shared across projects. Next, create a dedicated repository for these shared components and configure your projects to use them as dependencies. This can be achieved using Git submodules, subtrees, or package managers like npm or NuGet. Ensure that the shared repository is well documented and maintained, with clear versioning and update policies. This section will provide a detailed guide to setting up cross-repository sharing effectively. Scaling Git repositories requires a combination of best practices and tools. Regularly prune unnecessary data to keep the repository size manageable. Use shallow clones for CI/CD pipelines to reduce clone times. Implement Git LFS, large file storage for handling large binary files. Monitor repository performance and address bottlenecks promptly. Combine these practices with tools like Scalar and cross-repository sharing to achieve optimal performance and manageability. This section will outline key best practices for scaling Git repositories. Effective scaling and optimization of Git repositories require ongoing monitoring and maintenance. Regularly review repository performance metrics to identify potential issues. Use tools like GitHub Insights or GitLab Analytics to track repository health and performance. Automate maintenance tasks using Scalar's background maintenance feature or custom scripts. Ensure that all team members are aware of best practices and follow them consistently. This section will discuss strategies for monitoring and maintaining optimized Git repositories. To illustrate the concepts discussed, let's examine a case study of a large software project that successfully scaled its Git repository. The project faced challenges like slow clone times and high storage costs. By implementing Scalar and cross-repository sharing, the team significantly improved performance and reduced storage requirements. They also adopted best practices like regular pruning and using Git LFS for large files. This case study will provide a real-world example of how these strategies can be applied effectively. Scaling and optimizing Git repositories is essential for maintaining developer productivity and managing large codebases effectively. By leveraging tools like Scalar and implementing cross-repository sharing, teams can overcome the challenges posed by large repositories. Adopting best practices and ensuring ongoing monitoring and maintenance further enhance repository performance. As a next step, evaluate your current repository setup, identify areas for improvement, and implement the strategies discussed in this presentation. Continuous learning and adaptation are key to successful Git repository management.